We're going to be graphing quadratics in this video. For each quadratic, we're going to state the vertex, we're going to state the equation of the axis of symmetry, whether the quadratic has a maximum or minimum, and what that value is. We'll find the y-intercept, the x-intercept, and then finally we will graph it. When we graph quadratic equations, we want to make sure that we are doing that on graph paper to try and be as accurate as possible. The more accurate we are, the better the understanding we're going to have about these graphs. Now, graphing in vertex form is probably the most easiest to do. That's when we're in the form y equals a times the quantity, x minus h quantity squared plus k, where h comma k is the vertex. Before we get started, let's say this is graphing quadratics. Before we get started, I want to graph the parent function f of x equals x squared. We know that when we put a -3 in, we get a 9 out. And when we put a -2 in, we get a +4 out. A -1 in, we get a 1 out. When we put 0 in for x, we get 0 out. When we put a +1 in, we get 1 out. A +2, we get 4 out. And a +3, we get 9 out. So our graph is a parabola that is symmetric to the y-axis. So here's our y-axis. So that's the axis of symmetry right there that I've highlighted in yellow. That means that we have an equal distance. So there's an equal distance to the right of the axis of symmetry as it is to the left of the axis of symmetry. So anywhere on the parabola, the distance to the right of the axis of symmetry to a point that will be reflected over, those distances are equal. So this distance is equal to this distance. So D1 equals D2. So that's what symmetric means. The other thing is that the axis of symmetry, is an imaginary axis that goes through the vertex. And it's an equation of a vertical line. And that vertical line has an equation x equals h, where of course h comma k is the vertex. When the parabola opens up, we have a minimum. When it opens down, we have a maximum. Now you saw me graph this equation by putting values in and getting values out. However, there's another rule here. If you go right 1, up 1, right 1, up 3, right 1, up 5, and you keep adding 2, right 1 up 7, right 1 up 9, that will give you accurate points on your parabola, as long as the leading coefficient is 1. Once the leading coefficient changes, the 1, 3, 5 rule changes. Now I want to show you where that 1, 3, 5 rule comes from. So we have a 0, a 1, a 2, and a 3. When you put a 0 in, you get 0 out. When you put a 1 in, you get 1 out. There's your 1. When you put a 2 in, you get a 4 out. There's your change in y, which is 3. When you put a 3 in, you get a 9 out. There's your change in y, which is 5. So we call that the 1, 3, 5 rule. And I use it a lot when I'm graphing parabolas, and I'll use that in the next few examples. So here we go, our first example. F of x equals 1/2 x plus 4 quantity squared minus 3. We know that this positive 4 tells us that we're going left 4, and this minus 3 on the outside means down 3. And then we have a vertical shrink by a factor of 1/2. The parent function has a vertex at 0, 0. That vertex is going to move left 4, 1, 2, 3, 4, and down 1, 2, 3. So our vertex, which is the first thing that we need to find, that's our A. The vertex is -4, -3. The second thing we need to find is the axis of symmetry. The axis of symmetry is an equation of a vertical line that goes through the vertex. So with a highlighter, I'm going to create that vertical line at x equals -4. Because we don't have a reflection, this opens up. And when the parabola opens up, we have a minimum. And that minimum value is k, which is -3. So our minimum value is equal to -3. Next, we want to find the y-intercept. The y-intercept is the value of y when x is 0. So we're going to take our f of x is equal to 1/2. Instead of x plus 4 squared, we'll put 0 in for x. Half of 16 is 8. 8 minus 3 is 5. So our y-intercept is 0, 5. 1, 2, 3, 4, 5. Now, this happens to be 1, 2, 3, 4 units away from the axis of symmetry on the right. So we're going to plot a point 4 units away on the left. Now these 3 points you would think would be good enough for a nice picture, but we want a little bit more accuracy. We're going to find the x-intercepts. The x-intercept is the value of x when y is 0. So 0 equals 1/2 x plus 4 quantity squared minus 3. We'll add 3 and then multiply by 2. So we get 6 equals x plus 4 quantity squared. That's going to give us, if we square root both sides, we're going to get plus or minus the square root of 6 equals x plus 4. So x equals -4 plus or minus the square root of 6. So we have -4 plus the square root of 6, comma 0, and -4 minus the square root of 6, comma 0. That's approximately -2-ish and approximately -6-ish. So now we have f, we need to graph it. So a little bit more than -6, so I'm just going to put a point right there, and a little bit more than -2, so I'm going to put a point right there. Actually, it's going to be a little bit more, less than -2, because I'm going the other way. So I think it's going to be right about here. Let's see, 1, 2, a little bit more, 1, 2, a little bit more. Yes. Okay. Now, these are just estimates in between -1 and -2 for one x-intercept, and in between -6 and -7. And if you put that into a calculator, you'll see where those numbers are coming from. I'm just saying that the square root of 6 is 2-ish, so -4 plus a little bit more than 2 would be between -1 and -2, and -4 minus a little bit more than 2 would be -6 something. But what I really want to show you is that 1-3-5 rule. So the 1-3-5 rule, I'm going to write it over here. The 1-3-5 rule gets cut in half because of the 1/2. So 1/2, 3 halves, which is 1.5, and 5/2, which is 2.5. So we're going to go right 1 up, not 1, but 1/2, reflect it over. Then we're going to go right 1 and then up 1.5 and reflect it over. Then we'll go right 1 and we'll go up 2.5 and reflect it over. And then the next one would be 7/2 because 7 would come after that. So right 1 up 1, 2, 3.5 right there. And then we would have 4.5, right? 1, 1, 2, 3, 4.5. Reflect over. And using that 1-3-5 rule, we're able to get some pretty accurate points that draw a pretty awesome picture, other than the fact that it's a little pointy down here. Shouldn't be so pointy. But there you go. That is our first graph. So let's try another. We've got g of x equals -2 times the quantity x minus 1 quantity squared plus 6. Our vertex, which is very easy to find in this form, is 1, 6. So write 1 up 1, 2, 3, 4, 5, 6. Our axis of symmetry is x equals 1. So we'll take our highlighter and we will draw that axis of symmetry. Then C says, state whether the quadratic has a maximum or minimum. This negative right here is a reflect over the x-axis, which means this opens down. So opens down. Therefore, it has a maximum, and the maximum is equal to the y value of the vertex, which is 6. So that will be your maximum value in your range. Then D says, find the y-intercept. Remember, the y-intercept is the value of y when x is 0. So we'll put a 0 in for x, and we'll solve. -2 times 1 is -2, plus 6 is 4. So our y-intercept is 0, 4. 1, 2, 3, 4, and we'll reflect it over. I'm going to move this vertex over just a little bit there. Oh. There we go. I think I got it. No, I had it for a second. There we go. I just don't know if I can move it. I'm going to end up moving it too much. It's perfect, just like that. Not quite. There we go. It's a little lopsided. Then our x-intercepts are the value of x when y is 0, so -2 times the quantity x minus 1 squared plus 6. We'll subtract 6, divide by -2, which gives us a 3. Then we'll square root both sides, so we'll get plus or minus the square root of 3 equals x minus 1. Add 1, and we get 1 plus or minus the square root of 3. And the square root of 3 is about 1 point something-ish. So we've got 1 plus 1 point something-ish is a little more than 2. So 1, 2, so it's going to be somewhere between 2 and 3. 1 minus 1 point something-ish is going to be negative in between 0 and -1. So, or you can say right 1 and a little bit more, left 1 and a little bit more. So there's our two x-intercepts. Let me just delete that. There we go. Something like that. Okay. So we've got 1 plus the square root of 3, 0. And we have 1 minus the square root of 3, 0. And those are exact values. And then we've got our 1-3-5 rule. So now we can graph it. So we're going to graph with our 1-3-5 rule. So 1-3-5 becomes multiplied by 2 2, 6, 10. And it was multiplied by 2 because of this 2 right here. So write 1 down 2, we got that point, we reflected it over. Write 1 down 6, 1, 2, 3, 4, 5, 6, and we'll reflect that over. So 2 away, 1, 2, 2 away, 1, 2, and then write 1 down 10. We're not going to be able to make that, so we're just going to get really steep there. And there's a picture of our graph. Now it's wonderful when we have our function in vertex form, but here we have it in standard form, f of x equals x squared minus 6x plus 4. So we're going to find the vertex by completing the square, or you can use negative b over 2a. So you can find the vertex by completing the square, or by using h equals negative b over 2a. So for this one, I'm going to complete the square. F of x equals x squared minus 6x. I'm going to leave room to complete the square, and then I'm going to keep 4 on the same side of the equation. Half of 6 is 3. 3 squared is 9. I added 9, so now I have to undo that add 9 and subtract 9, so that I zero out what I just did. So I have f of x equals, this part right here is the part that I needed, x minus 3 quantity squared minus 5. This part right here is where minus 5 is coming from. So our vertex is 3 comma negative 5. Write 3 down 1, 2, 3, 4, 5. Our axis of symmetry is x equals 3. We'll take a highlighter and we will draw the axis of symmetry. C says whether or not you have a maximum or minimum. This opens up. Therefore, we have a minimum, and that minimum value comes from the y coordinate of your vertex, so that's negative 5. Our y-intercept, f of x, is equal to 0 squared minus 6 times 0 plus 4, which is 4. So our y-intercept is 0, 4. This looks very strange to me, so I'm going to just erase that and draw it a little bit better. There. Okay. And we have our x-intercepts. The x-intercept is the value of x when y is 0. So we have 0 equals x squared minus 6x plus 4. This is not factorable, so we have to use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2. We'll extend the page. X equals 6 plus or minus the square root of 20. 36 minus 16 is 20, all over 2, which is 6 plus or minus 2 times the square root of 5, all over 2. So our x-intercepts are 3 plus or minus 5. So 3 plus or minus the square root of 5. 3 plus the square root of 5, comma 0, and 3 minus the square root of 5, comma 0. Now the square root of 5 is 2 something. So 3 plus 2 something is about 5 something. So 1, 2, 3, 4, 5 something. Reflect it over. A little bit more than 2 to the right, so a little bit more than 2 to the left. And 3 minus 2 something is between 0 and 1. So that makes sense. This is the 135 rule because we have an A value of 1. So write 1 up 1, write 1 up 1, 2, 3, write 1 up 1, 2, 3, 4, 5. Reflect those over. I forgot to graph the 0, 4, but that's okay. It did it for me. Now, I made a little bit of a mess here with this, so I'm just going to kind of clean that up a little bit. Then we'll come back over here, write 1 up 1, 2, 3, 4, 5, 6, 7. So I'm just going to draw that for a target so that I can enter and exit my graph accurately. And there's our beautiful parabola. Next example, h of x equals negative 2x squared minus 8x plus 3. This one would be another good one to complete the square, but I do want to show you how to use that negative b over 2a. So we're going to find the vertex by taking h equals the opposite of b, which would be positive 8, over 2a, 2 times negative 2. Now 8 divided by negative 4 is negative 2. So the first value of our vertex is negative 2. The second value of our vertex is found by putting that negative 2 into the function and computing. So we have negative 2 times 4 is negative 8. So I have negative 2 times negative 2 squared. Negative 2 squared is 4. 4 times negative 2 is negative 8. Minus 8 times negative 2, which is positive 16. And then we have a plus 3. So we have 8 plus 3 is 11. 8 plus 3 is 11. Let's make sure that we did that right. We had negative 2x squared plus 8x minus 8x plus 3. So negative 211 is just off the chart right here. Negative 211 is right there. Our axis of symmetry, that is correct, right? 4 times negative 2 is negative 8, plus 16 is 8, 8 plus 3 is 11. Our axis of symmetry is going to go right through x equals negative 2. It goes right through the x value of our vertex. Draw that just a little bit better there. That'll be one more time. It's as good as it's gonna get. And there's my vertex right there, negative 2, 11. Then C says, do you have a maximum or a minimum? Because this opens down, I'm gonna have a maximum, and that maximum is equal to 11. My y-intercept is the value of y when x is 0, so that's going to be 0, 3. And my x-intercept I can find using the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to be the square root, actually, that's going to be 2 times a is negative 4. Let me give myself a little bit more room here. 8 plus or minus the square root of 64 plus 24 is 84. So that's going to be, and that's all over negative 4. So that's going to be 8 plus or minus 2 times the square root of 21 all over 4. Negative 4. So I've got negative 2 plus or minus let's do it this way. 2, 2, 2. So 4 plus or minus the square root of 21 all over negative 2. So I'm going to bring this negative to the top, and I'll have negative 4 plus the square root of 21 all over 2, comma 0, and I'll have negative 4 minus the square root of 21 all over 2, comma 0. Now I'm pretty sure this is right. If I've made a mistake, I'm in big trouble. Big, big trouble. We'll see though. F is the graph. Now this is not the 1, 3, 5 rule. This is going to get multiplied by 2, so it's the 2, 6, 10 rule. So we go right 1, down 2, reflect over, right 1, down 2, reflect over, and I can already see that something is in error. H equals the opposite of B over 2A, negative B over 2A, so that's negative 2. Negative 2n, that's definitely an 11. I think I can't count. I think that's where I made my mistake. I can't count. It's late. Do you see? It's 9:11 p.m. Right 1, down 6. 1, 2, 3, 4, 5, 6. There we go. So it's a good idea to check to make sure that everything's copacetic. Then we're going to go right 1, down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll reflect over. And voila. Look at that graph. And look at your patience. That's pretty darn amazing. Now, if you were to put into your calculator negative 4 plus the square root of 21 and divide by 2, you're going to get a number 1, 2, 3, 4, somewhere between negative 4 and negative 5. And if you put in, if you put in negative 4 minus the square root of 21 over 2, you'll get negative between negative 4 and negative 5. If you put negative 4 plus the square root of 21 all over 2, you'll get between 0 and 1. Promise. I promise, I promise. And I'm pretty darn confident about that. So hopefully you got a good idea of how to, and you can use whichever you prefer. You can use completing the square, which some people really like to complete the square. So you can complete the square to put your quadratic into vertex form, or you can use h equals negative b over 2a and find the x value of your vertex and then plug that back into your function to find the corresponding y value. Either way works. It's really just personal preference.